All right, this is the final block for Python. We're going to talk about classes in the same sense that you have classes in Java, C++, C Sharp, and other languages, but not in C. C itself does not support classes as we know them. You can, of course, fake them out, but that's not what we're going to talk about. So in Python, classes are object-oriented. No offense, but it's kind of a hack. The language was defined in like 1989, and object-oriented stuff wasn't that big a deal until in the mid 90s and so on. It existed since the 70s, but it wasn't really very extensively used until C++ started to become popular in the mid 90s. So when Python was originally defined by old Guido von Rossum, he didn't put it in. But then later on it was put in. And so there's some quirks that we're going to see here. This is a part of Python that gets fairly weak marks in my book. But in any case, that's an opinion. But in any case, it works. So let's go through it. So object-oriented in Python means that we have classes, we have methods and fields within those classes that perform as you're used to. Not only can you have methods and fields, but you can have both instance level and class level, just like you can in various other languages. The instance level ones means you can have one for each and every instance. Class level ones means for a field means that it's shared across all instances. So it's in some sense like a global sort of. Okay. It does not support the concepts of public and private, at least not directly. You can make it. You can do that yourself by creating a private object inside and encapsulate it. But the language itself does not support it. You do not have things like public, private, protected, and so on. Package level. Everything is public. For better or worse, it's just the way it is. And it does have reflection, which we're not really going to talk about. It's in the notes. Down at the bottom, you'll be able to see some stuff. It's a very powerful feature, and it's very cool. It's much easier to use in Python than it is in Java, which also has reflection, to get the metadata about your program itself, your classes, and so on. But we're not really going to cover it. Okay, so first we're going to give an example of how to actually create an instance. To create an instance of a class, we don't use the keyword new. We just call the class name and give it the parameters that the constructor needs. So this is a constructor for the employee class. This is an instance of calling the constructor for the employee class again. Okay. We pass in parameters to the constructor just like we do in some other languages. But remember that Python does not support overloaded functions. Okay, so you can only have one constructor, and you have to have one constructor, but there's a default one provided for you. Okay, and you inside your constructor, if you want to accept different input parameters to the constructor, you can, but you have to use some of the tricks that we used before of having optional parameters and so on. Okay, so to create a class, we use the keyword class. And like everything else in Python, it ends in a colon, and all the stuff goes underneath it indented. And it has to be exactly indented. Okay, if you'll notice, this is perfectly indented to 4 spaces. By convention, the first line inside of a class should be some kind of a document string. If it fits on one line, you can get away with a single quote, but typically you want this thing to be fairly verbose. So typically we use the triple quotes, which means it can span across multiple lines. Something like this. Something like this is much more common. Okay? So you can define a class, but you can also give some documentation as the first line inside there. And some of the IDEs and so on know and expect that. They know that this is the description. But that's a convention. That's not a That's not really a part of the language. This is optional. Okay. So any assignments that happen outside of a define, outside of a function definition, are automatically class level variables. Okay. So this last ID here is part of the class. It's not inside of a function. Method now, I guess you could start to call these things methods. It's not inside of a method, so it is a class level variable. So employee.lastID, not instance.lastID. Okay. Now, for whatever reason, the constructor has a very special name. It's double underscore init double underscore. It's hard to see that this 2 underscores before and 2 underscores afterwards. Okay. This defines the constructor. There can only be one constructor per class. So employee, this is the one and only. If you don't do this, it's okay. It'll create a sort of a default init for you automatically. Okay. Now, on to the hacks. Okay. Self. This is a, let's give it a C minus 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 for Guido. Or whoever invented this. Maybe it wasn't him, because it did not come in as part of the original language in Python 0.1. You have to pass self around. Now in Java, you've seen the word this. So quote this in Java is the same as quote self in Python. Self-referencing, it refers to the instance of an object, of a class, an instance of a class. Okay. So if you have an instance of employee, when you create it in the constructor, okay, you have to reference it by the name self. So all these 5 variables that you see here are all going into that instance of employee, not the class level. So this last ID is shared across all instances, whereas these 5 fields are specific to each one. So in other words, each employee has their own name and their own prefix, salary, exemptions, and ID. Okay. Again, notice that there's no declarations of anything. When you have a class, you can add whatever fields you want and check whatever fields you want. There is no control that you have. If you want to introduce a new field on an object in a class, you can do that no matter what the definition of that class is. There's no concept of a closed or final class. Okay. There's really no reason, or generally not very many reasons, but I can't think of a whole lot, to put class methods attached to the class instead of an instance, unless you don't want to ever create any instances. Okay. So this generate ID class method is not, you don't call it off of an instance. You say employee dot generate ID. Okay. And you notice inside here, there is no self. Okay. There's no self associated with this. Okay. So in it, you explicitly have to put the word self in there. And anything you want to store on that object, that instance of that class, you have to explicitly say self. So when you're dealing with classes, mostly it's good, but you'll see a lot of self, 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 self. Okay. And it gets old after a while. Okay. So when you actually want to do a method, this is a true method. Okay. You actually have to pass in self. And all your references have to say self dot, self dot, self dot, self, self dot, self dot. I mean, look at this, right? So this is a fairly weak thing, but it works. Okay, it works. Okay, you can actually do real work. Okay. So if you don't put the word self here, what happens? Right, you get a local variable. Right, the local variable lives for the duration of the function or method definition. Once that definition is complete, this thing called, if you deleted this, right? Actually, let's do it on an assignment. Where's their assignment? Here. If we deleted this, then last ID would only be alive for the duration of this method and would go away. Okay. If you want to keep it in the class like here, or you want to keep it in the instance, here's one, self.bonus. Okay. If you take that off, then this bonus just is a local variable. Okay. All right. So this is it does work. I mean, you can do an awful lot with classes, but you can't control how they're used. In other words, without the lack of public and private, without the ability to control what methods are attached or what fields are attached, anybody that uses your class or your instances of the class can change the structure, the metadata associated with that class or that instance, which isn't so great. Okay. So if you want to do inheritance, Python completely supports it. In fact, it supports multiple inheritance. Java, as you know, can only inherit from one class, but can implement the interface, multiple interfaces. Python is like C++, probably indicative of when it was created, because Java wasn't really well known until the end of the 1990s, whereas C++ and Python came around significantly before that. So it supports multiple inheritance. To create a class or define a class with this name, we can tell it that we want to inherit from a list of superclasses. That list can be empty. Okay, in this case, there's one. Okay, so for example, manager inherits all the stuff that an employee can do and adds some of its own stuff. Okay, apparently managers can get bonuses whereas employees cannot. I guess that's fairly typical, right? For the cynical group of us. Okay, so you can put multiple classes to inherit from above. Strange things can happen. I'm not a fan of multiple inheritance. I prefer the Java approach of single inheritance, but multiple interfaces, implementing multiple interfaces. But again, that's an opinion. That's a preference. It's not a fact. Okay. With multiple inheritance, you can pull the functions and fields, methods and fields from more than one class at the same time. Okay, so it's very powerful, very flexible. There is a function called super. Actually, I guess it's a method called super to grab a class's superclass. Okay, so if you're in this class and you say super, well, now you're in this one. Okay, and you can call its constructor explicitly if you wish, which you have to do in many cases. You can call its super constructor and pass in whatever parameters you need to. Okay, you can also directly call methods on that superclass if you wish. Okay. Polymorphism, okay. You can check. You can have if you have a class that inherits from another one, like subclass manager inherits from employee. You can deal with employee and pass it a manager object, and it will still work. You can't do the opposite, right? You cannot take an employee object and use it as a manager. That doesn't work. But you can take a manager object and call the employee methods on it. Okay, that's what this is showing you. Okay, encapsulation is just like other languages, no big deal. You can hide stuff inside, and typically what we do is we will often explicitly encapsulate an inner class. Okay, and I do this myself. Okay, so you can have a class inside of a class. You can have functions inside classes, classes inside functions. Python doesn't care. Okay. All right, so we have an inner class here, and we're doing some stuff with it. I'm not going to go through this example. Don't think it's very important. And then examples 6 and 7 are similar, two different approaches to the same problem. But I do want to talk about try and except. So you're used to, I hope, try and catch from Java. Try and except is Python's way of doing the exact same thing. In fact, it even has finally. Okay, so you can give it a list of exceptions. Syntax is a little bit easier. You can just say try except : You don't have to say what you're catching. So all this stuff will do if this exception gets thrown or raised in Python terminology. If this exception gets raised, it will perform the tasks inside that block. Okay. All right. I know I'm kind of blowing through this stuff, but we're running out of time in the semester, and I want to get through it. Okay. Is instance and is subclass. I think you can tell what these do. This is just a way to check to see if something is an instance of or a subclass of another class. It's kind of obvious, right? And then we're going to skip this whole thing on reflection. Okay. I do want to say that reflection is one of the things that if I'm interviewing somebody, and I interview a lot of people, if you're interviewing somebody, this is one of the things I will typically ask to get a good gauge. I ask about synchronous. I want to know if they understand what it means to be multi-threaded and some of the implications of that. And I also want to see if they understand the idea of reflection, to know that you can actually look at your own class or another class and see what methods are on it and what data fields are on it and perform actions on those. Even if you're just handed an instance of an object and you don't know anything at all about it, which is kind of cool. But a little bit beyond the scope for what we're going to cover in this class. Okay? And that's what these examples are showing. Okay? And you have the notes. Again, if you're interested, feel free to go through this material.